Hi, if you missed the second part of our discussion about graphing absolute value functions, you can catch up here today. So those of you, especially if you went on the FFA field trip, or I know there's a couple of students I have that are quarantined, and if you missed class, this is a good one to get caught up on. Okay, so we've been talking about absolute value graphs. If we look back to our discussion yesterday, here's kind of the main things we talked about. Okay, absolute value graphs are going to be a V. They have a vertex and they are symmetric. If you look at the coefficient in front of the absolute value bar, that's going to determine how wide open your V is, and is also going to determine whether it opens up or down. So you can see on example 2, it's a 1/4, it opens up. And on number 3, that number in front of that absolute value is a -2, and it's going to open down. Okay, then we looked at what happens if you add or subtract a number inside of the absolute value bars, and that is going to shift you horizontally, so either to the right or to the left, depending if it's a -2, it's going to go to the right, +3 is going to move to the left. Then we looked at what if you add or subtract on the outside of the absolute value bars, and that moves your vertex up and down. So up 3 or down 3 units. Okay, then what we're going to look at today is, all right, so if we put all of those pieces together, what does our graph look like? And finding a more efficient way to graph it than plotting lots of different points. Okay, so if we take a look at this, and let's pull out some of these characteristics that we saw earlier. So right here, this number in front, your -2, that is going to tell me that my graph is going to open down. Okay, that -2. This 1 right here is going to tell me that I'm going to go left 1 unit. And then this -2 tells me I'm going to go down 2 units. Okay, now I know you may be thinking, well, that's a positive one, so why did she say move it to the left? Trust me, it moves left. We'll talk more about why in a couple of minutes. Okay, so if we think about that original parent function that has a vertex at the origin and then opens up. Okay, well, if we shift this vertex 1 unit left and 2 units down, well, then that vertex moves to here. Okay, so it moves -1, -2. Okay, so I'm going to label here a little bit. Okay, so my vertex gets shifted, and it's going to be at -1, -2. Okay, so my suggestion on using your table is figure out where your vertex is and put that in the middle of your table. Okay, and then we're going to work out from there. Because this graph has symmetry, okay, you've got 2 halves that match up. Okay, so if, so here's our vertex. Let's say we choose 0 and 1. So I'm increasing by 1 on both of those x values. So if I decrease on 1 by 1, then that's going to go -2 and -3. Okay, so if I take 0 and plug that into my equation, so y equals -2 times the absolute value 0 plus 1 minus 2. So this is going to be -2 of 1 minus 2, and that equals a -4 at 0. Okay, now if I plug in -2, okay, I get absolute value of a -1 here minus 2, so that comes out as a +1. So it's -2 times a +1 minus 2. Well, you get -4 again. Okay, all right, that's how your table shows the symmetry. Okay, so you have these two where the y values match up. Okay, now I can plug in the value of 1, do my arithmetic, I can do all that. It's gonna be a -6, so you can do that if you want to stop the video and just plug that in. Okay, when I do -3, that's also going to be a -6. Again, you see how this symmetry matches up. So 0, -4, 1, -6, and then I've got similar points on the other side. So here is my absolute value graph. So vertex at -1, -2, and it opens down just like we predicted from that -2 in the front. Okay, now something else I want to show you, and that might be helpful, is yes, this value is -2, and so it opens down, but that 2 also affects the like the steepness, okay? So if you think about that -2 as -2 over 1, and think about slope, rise over run, okay? Once I have that vertex, and then if I go down 2 over 1, down 2 over 1, there's that half of my absolute value graph. And because I know absolute values are symmetric, if I go down 2 and then go 1 the other direction, again down 2, 1 the other direction, then there's my other half of my absolute value graph. Okay, so you can kind of think about that first value as being slope. Okay, so let's kind of use that idea here. Okay, so this one, -3, that's going to open down. And then let's see if we can figure out where the vertex is. So from 0, 0, well, there's nothing inside of the absolute value bars, so there's no horizontal shift on this one. But if you look here, we do shift down 2 units. Okay, so if our vertex starts at the origin, it does not shift left or right, but it does go down 2, then my vertex is going to be at 0, -2. Okay, now remember this conversation we just had with this -3. Okay, so that -3, we're going to call that the A. Okay, or think of it as -3 over 1, and think rise and run. Okay, so if I go down 3 over 1, and I could kind of estimate down 3 over 1 again, but there's one side of my absolute value. If I go down 3 and go the other direction 1, and then do that again, there's the other half of my absolute value. So I just graphed my entire graph, and I didn't do one point in that table. Okay, so use these patterns that we find with these graphs, and it's gonna you can make it more efficient for you. Okay, but let's say you're not real confident about that, especially that slope thing is kind of throwing you. So if you can pick out where that vertex is, that 0, -2, that's going to help a lot. So if I can say, okay, I know where my vertex is, so I know now when I pick values on either side of my vertex that these are going to be those points that are going to match up. So whatever 1 is going to be, -1 is going to be the same thing. So this is going to be a -5, this one's going to be a -5. This will be a -8, this will be a -8, and those y values are going to match up. Okay, so let's look at it from this perspective. All right, so A times absolute value of x minus h plus k. That A, if that A is a positive number, your graph is going to open up. If A is a negative number, that graph is going to open down. Okay, also that A kind of acts like slope. Okay, it tells you whether your graph is going to be wide or narrow, or the steepness of the graph, you might say. H is a horizontal shift. HK is a vertical shift, and your vertex can be found from HK. Okay, so that's what we just summarized. All right, so let's talk about these. Predict. Well, it's going to be a V that opens down. My A is -1, so it's going to open down. My vertex, HK, is going to be -4, -8. Okay, so right here, okay, look how this equation is x minus h inside the absolute value bar. So if I were to rewrite this, x subtracting something, I'd have to subtract a -4 to turn it into a +4. So therefore, your h is a -4 and k is -8. I say change the h, keep the k. Okay, so change that sign inside the absolute value bars to find your h, and then keep the sign on the outside for your k. So same thing here, my a is 2/5, it's positive, it's going to open up. My h is 1, my k is 3. Okay, so my vertex is going to be at 1, 3. Okay, so what's getting subtracted? X subtract what? It's subtracting a 1. H is 1. K is 3. Okay, so horizontal shift, vertical shift. Okay, all right, so let's do these. Oh, I didn't get these erased. Okay, so here is the reverse. Okay, so let's look. Here is the vertex. That vertex is at 2, 1. Well, basically I need to find my h and my k and my a, and then I'm good. So if my vertex is at 2, -1, then my h is 2 and my k is -1. So x minus, what's getting subtracted? My h, which is a 2. And then my k, keep that just as a -1. Okay, to find my a, we know a is positive because my graph is opening up. I'm going to go from the vertex, and then it looks like my graph does a good job crossing right there. So if I count that slope, up and over, I go up 7 and over 4. So this is going to be 7/4, and there's my equation. Okay, this one, my vertex is at -2, 0. So there's my h. So h is a -2, k is a 0. So x minus a -2 is going to end up x plus 2. And then plus 0, I don't have to put that on there if I don't want to. Okay, now this one opens down, so I know my a is going to be negative. But here, well, or I could count to here. So if I go start at my vertex, I'm going down 2 over 1. So down 2 over 1, or just -2. So there's my equation for these two graphs. Thanks for joining me, and I'll see you next time.